Bismillahirrahmanirrahim. Dear students, we are studying the subject Science and Technology part 1st and our lesson is Gravitation. Dear students, we have studied in our last lecture the Kepler's three laws. First law, second law and third law and Newton's universal law of gravitation. In this lecture, we will study about the uniform circular motion or magnitude of centripetal force. So what is this? It is when an object moving in a circle with a constant speed towards the center is called as centripetal force. Dear students, we have studied about the circular motion. So what is the circular motion? We have experienced this with the object and the string. When we move an object with the string in the circular motion, it is called as circular motion. And when the speed is constant, dear students, the main point is the speed should be constant, then and then it will called as the uniform circular motion. Okay, here if the m is the mass of an object, the object we are using indicated by mass, and v is the speed the velocity or the distance travel and divided by that is time taken, and r is the radius is the area, then the force will be F is equal to mv square upon r. So it is the formula for the force of gravitation, that is m is mass, v is velocity and r is for radius. Okay. So dear students, it is the formula that is used for the earth surface. But what is about our solar system? We know that Kepler gives us three laws. That first law that indicates the elliptical motion, second law that is occupy the same area in the same period, and third law gives us the directly proportional between time and area in the proportion of square and the cube. So for the planet revolution, we know that our planet or the solar system is in the elliptical motion and sun is our on one foci and one planet. If the planet is rotating in the orbit in the same speed, that will call the uniform circular motion of an orbit. So we have to derive this by this distance and the formula, that is revolution. For the planet revolution, we have seen that what is the revolution? Revolution is the speed of planet or the time taken for the to complete one rotation for the one planet, and the distance traveled by the planet one revolution of orbit, it is the perimeter of 2 pi r. The value is given for the orbit of revolution and the planet for the revolution, that is perimeter of 2 pi r. R is the distance of the planet from the sun. T is the time taken for the revolution. So the formula is V is equal to distance traveled by time taken. We have to use the formula for the velocity, that is distance traveled by time taken. The values are given. We will put here, and 2 pi r distance traveled, perimeter of 2 pi r we will write here, and time taken, that is our t divided by t. Then the force will be F is equal to mv square upon r. Here is our formula for the force, that is mv square upon r. Therefore, by putting the values in the orbital form, that is m 2 pi r. 2 pi r square the value, it is we will use here by t, and divided by r. R is the radius. Therefore, we will get after squaring that 4m pi square r upon t square. Okay, in next step, F is equal to 4m pi square upon r square. Okay, according to Kepler's law, according to third law, that is, we have seen that the square of time is with the directly proportional to the r cube, and for the constant we have formula t square upon r cube. Therefore, 4m pi square upon r square cube. Kepler's, k is the Kepler's constant. It is the value for the various orbits or the planets which are rotate in the solar system. So, by this formula we can calculate the force. You know, students, our solar system, there are various types of planets and they rotate around the sun. Sun is the center of all the planets. All the planets rotate around the sun and it is the center. Therefore, there is also a centripetal force, which means in solar system there is also a centripetal force, and the center of all the planet is our sun and all the orbits rotate around the sun. Okay, so it was about the uniform circular motion and magnitude of centripetal force. So towards one problem, mathematical problem, we will calculate the force. Example is, Mahindra and Virat are sitting at a distance of 1 meter from each other. Their masses are 75 kg and 80 kg. So we have to calculate the gravitational force between them. Suppose there are two boys named Mahindra and Virat and they are seated from each other with the distance of 1 meter. Okay, distance is the area, that is 1 meter, and M1, that is of Mahindra, having the weight of 75 kg, and M2, the second boy, that is Virat, is having the weight 80 kg. So we have to calculate the force of attraction. What will be the force of attraction or the gravitational force between two boys? So solution we will get that. The given values we will keep here. R is the radius or the distance, that is 1 meter. M1, that is 75 kilogram, and M2, that is 80 kilogram. And G is the gravitational constant. This value we have to always use. It is constant, it cannot be changed. So we have to use this value in all the formulas. Okay. So according to the Newton's law, we have formula for the force, that is F is equal to G into M1 into M2 upon R square. By putting values, F is equal to the value of G is 6.67 into 10 raised to minus 11 into M1. What is our M1? M1 is 75 kilogram. Into M2. What is the value of M2? That is 80 kilogram. Okay, and divided by R. R is the radius that is given in the 1 meter. So we will calculate this value and we will get the answer is 4.002 into 10 raised to minus 7 Newton. Okay, so the gravitational force between two Mahindra and Virat, these two boys, is that 4.002 into 10 raised to minus 7 Newton. Okay, now we will study, we have just studied our new topic, that is uniform circular motion or magnitude of centripetal force. Now we will move towards our new topic, that is Earth's gravitational acceleration. Dear students, according to the Newton's second law of motion, a force of acting on a body results in its acceleration. Thus, the gravitational force due to the earth on a body results in acceleration, and it is called as acceleration due to gravity. It is denoted by G, acceleration is a vector quantity. Dear students, according to Newton's second law of motion, when an object is running on the earth or an object is on the surface, a force acts on it and it is called as the acceleration. Okay, and what is acceleration due to gravity? When the gravitational force of earth acts on the that body, that is called as the acceleration due to gravity. Here it is denoted by small g. Dear students, small g is the acceleration due to gravity, and we have used capital G also here, that is universal gravitational constant. Okay, it is all about Earth's gravitational acceleration. So our next topic is value of g on the surface of the earth. So value of g, we have to obtain or calculate the value of small g. Small g is the acceleration due to gravity. We can calculate the value of small g by using Newton's universal law of gravitation. Dear students, we have studied earlier Newton's universal law of gravitation. For an object, if the mass is m situated at the distance r from the center of the earth, then the force will be F is equal to capital G, capital M, small m divided by r square. Dear students, here capital G is the universal gravitational constant. So for g value we have to calculate F is equal to mg, because mg is equal to g capital G, small capital M and small m divided by r square. By cutting small m, we can get the value of small g, that is capital G into capital M divided by r square. Dear students, g we know the universal gravitational constant, and capital M is the mass of the earth. It is mass of the earth. The value of it, that is 6 into 10 raised to 24 kilogram. Next, capital R. What is capital R? It is the radius of the earth, that is denoted by capital R. Small r is equal to capital R, and the value is given, that is 6.4 into 6 raised to 6 meter. So for calculating the value of g, we have to calculate all these values by putting them, that is g 6.67 into 10 raised to minus 11 into m, value of capital M, that is 6 into 10 raised to 24 divided by capital R square, that is the value given here, that is 6.4 into 10 raised to 6 whole square. So by this formula we can calculate this value, that is 9.77 meter per second square. So dear students, it is the value of small g that is used for the acceleration due to gravitation. So we have studied today uniform circular motion or magnitude of centripetal force, Earth's gravitational acceleration, and value of g on the surface of the earth. So we stop here. Till next lecture. Allah.